Hello.
Yes, sir.
Okay, my voice is audible, right?
Yes, sir.
Okay, I have shared the screen. You are able to see?
Yes, sir.
Yes, sir.
Okay. Okay, fine. So in DC circuits, in part one, we have seen different methods to just analyze to some extent. Okay, so using KVL, KCL, how to calculate powers, how to using other methods like nodal analysis and mesh analysis, how to analyze circuit. That means analyze means how to calculate how much power is being consumed by that element or whatever it may be. Okay, right. So these things we have studied. So now we will go to part two. This is also a simple extension of that. Here we will study three more techniques uh, regarding analysis of circuits. If the circuit is a little bit more complex, then we can reduce it to a smaller circuit. Okay, so the actual circuit and the reduced circuit both will have the similar effect on your load. That means when you are analyzing, it will not create any difference. That means the equivalent circuit we are trying to form, which is a very small and easy to understand compared to a complex circuit. So those kind of techniques we will see in this part 2. Okay. Okay. So coming to this, first of all, what is linearity and superposition? Okay. So we have already seen a passive element which is called as a resistor. Okay. So there we have seen that resistor is a linear element. So how we actually define linearity, whether element is linear or not, how we will state. So okay. So linearity is basically we define a linear element as a passive element that has a linear voltage current relationship. Okay. So that means to call an element as a linear element, we should have a linear voltage current relationship. So that means you are measuring the voltage across the element and current flowing through the element, both we are measuring. So if you keep on increasing the voltage, the current also increases in a linear fashion. Then we will call it as a linear element. Okay. So by linear voltage current relationship, we simply mean that multiplication of the current through the element by constant k results in the multiplication of voltage across the element by the same constant k. Okay, that means it's a straight line. If you plot a graph between v versus I across the element, you will get a straight line. So when you get a straight line, we call the voltage current relationship is linear. So if any element exhibits this kind of characteristic, then we will call it as a linear element. Okay. So resistor we have already seen. Resistor is called as a linear element because as per Ohm's law, if you see V of t, if you are plotting graph between voltage across the resistor and current flowing through the resistor, you will get a straight line. Okay, so that linearity is basically you will have a constant, proportionality constant, which is denoted by R. That is the value of a resistance of the element in ohms. Okay, so resistor is a passive linear element. Okay, so next we will see what is linear dependent source. We have seen four kinds of sources. Okay, I mean basically two kinds of sources. One is independent source, another one is dependent source. In independent source, independent current source, independent voltage source, and in dependent source we have seen four categories. Okay, so linear dependent source means what? Okay, a linear dependent source is a dependent current or voltage source whose output current or voltage is proportional only to the first power of a specified current or voltage variable in the circuit, or the sum of such quantities. So what it means is you have actually seen a linear, we have already discussed regarding a dependent source. So what it states, whether it's a dependent current source or dependent voltage source, it actually depends on some other variable. It could be a current or it could be a voltage in some other part of the same circuit. Okay, so that we have called it as a dependent source. When you talk about linear dependent source, it's the same thing, but it should depend on one variable with first power. That means it should be depending on voltage or current. That's all. It should not depend on voltage square. That means Vx square, some other variable, or Ix square, or product of V into I. If it is depending in that fashion, then we will not call it as a linear dependent source. Right. If you see, I have given here an example. Vs is equals to 0.6 into I1 minus 14 into V2. So that means if your voltage, it's a dependent source, I am representing with Vs. Okay, it's a dependent voltage source. It is depending on current I1 at some other part of the circuit and depending on V2 at some other part of the same circuit. Okay. Okay. So this can be called as a linear. This can be called as a linear dependent source because it is depending only on power 1. I1 power 1 only. Okay. Right. If there is a scenario that your voltage output of an dependent source is depending on I1 square into some constant or depending on product of V1 into I1 into V2 multiplied with some constant. If this kind of scenario is coming, it is called as a non-linear dependent source. Okay, right. So this is how you have to differentiate between a linear dependent source and a non-linear dependent source. Okay, we will consider only linear dependent sources in our circuit. Okay, if you see in the previous examples also, we have considered only linear dependent source because for these theorems what I am going to discuss in the next slides, those are applicable only for linear circuits. Okay. Right. So we have seen a passive element resistor, which is a linear element because their relationship is linear, and we have seen what is linear dependent source. Okay, linear dependent source. You can see in example 1, it is linear, and in example 2, it was given here, it is non-linear. Okay. So now we will define what is a linear circuit. We define a linear circuit as a circuit composed entirely of independent sources, linear dependent sources, and linear elements. That means, please switch off your mics. So that means what it is saying, if you want to say one circuit is a linear circuit, it should not violate this condition. That means it can consist of independent sources, current source or an independent voltage source. It can consist of linear dependent sources, okay, right, and linear elements. So linear elements also it can consist. It can consist all these three or any combination of two, okay, whatever it may be. But okay, so if you have in a circuit an independent source or a linear dependent source or linear element, then we will call that circuit as a linear circuit. Okay. So coming to theorem 1, this is called as superposition theorem or superposition principle. Okay, so that means if you have a circuit, you can apply this theorem based on the situation. That means if you feel by using this theorem or by using this principle, it could be easily solved, you better go for this analysis. Okay, if you use another analysis method like nodal analysis or mesh analysis also, you'll get the same answer. Okay, nothing is going to be vary. Okay, so if you see the circuit and if you feel it is easy to solve using this methodology, you can adapt this method. So what it states is in any linear resistive network. So that means that's why I have discussed about in linear circuit. Okay, linear resistive network. That means it should consist of a linear independent sources or linear dependent sources or resistors. Okay, Okay. In any linear network, the voltage across or current through any resistor or source. This is what actually we'll calculate. If you see in the previous examples, we are interested in finding the current flowing through particular branch or voltage across any particular branch we have calculated. Okay. So in a linear circuit, the voltage across or current through any resistor or source may be calculated by adding algebraically all the individual voltages and currents caused by separate independent sources acting alone. So what it states is, if you have in a circuit more than one independent source, okay, we have already seen that scenario, right? If you have one independent source and one current source, or two independent sources, or two current sources, whatever may be the combination, n number of sources, you can have 100 number of sources, no issue. Okay, so what it is saying is, if you have those many sources, find out the voltage across your branch or wherever you're interested, or current flowing through the particular branch wherever you're interested, for each source acting alone, independent source acting alone. Okay, so that means if you have a circuit consisting of two dependent sources, two independent sources, okay, whether it is voltage source or current source, whatever it may be, if you have two independent sources, you have to, I mean, you can resolve the solution for that circuit in two stages. Okay. Okay. First stage is you will consider only one independent source and solve it. Next, you will consider another independent source and you will solve it. And then you have to add algebraically all the results what you got. Okay. So that means if you have more than one source, you can find the solution. The solution means current in a branch or voltage across the branch. Okay. By algebraically adding the individual responses when independent source is acting alone. Only one independent source is acting alone. Okay. Anyway, once you see the example, mostly you'll get understand better. Okay. So if you are considering one source, what will happen to the other source? Let's say stage 1, there are one voltage source and one current source is there. You are considering only voltage source and current source. You will not consider at stage 1. Okay, so what to do with current source? With all other independent voltage sources replaced by a short circuit. That means if you are removing an independent voltage source, you will replace with a short circuit. That means zero resistance. If all other current sources are replaced by open circuit. That means if you have a current source, independent current source in the circuit, you will replace with a open circuit. Okay, so what it is stating is, if you have more than one source in your independent source in your network, you have to solve it using at two stages. Okay, so stage 1, let's say you consider only voltage source. Okay, one voltage source and one current source are there. You are considering voltage source and you will replace your current source with an infinite resistance. That means open circuit and solve it. Okay, stage 2, what you will do? You will consider the independent current source and voltage source should be replaced by short circuit. That means zero resistance. And you will solve it and you will find the response. The response means current in any branch or voltage across any branch. Okay, then the two stage results what you have got, that you have to add algebraically to get the net output. Okay, anyway, once you go to the example you will understand better. Okay, dependent sources remain inactive in the circuit. That means if you have dependent source present in the circuit, we are not going to change anything. They will remain as it is in your circuit throughout your analysis process. Okay, only independent voltage source will be replaced by a short circuit. Okay, at stage 1 if you are analyzing. Okay, and independent current source will be replaced with an open circuit. That means infinite resistance. Okay, and dependent sources remain active. That means they are not going to change. They remain as it is in your analysis process. Okay, let's see this. This is applicable only for linear networks. Okay, So let's see here. Okay, so my voice is audible to you, right?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so we'll see one example. You can solve any network using any of the methodologies till now what we have discussed, or what methodologies we are going to explain in future also. Any method you can adopt. Okay, that is your choice. Okay, but if I specifically ask something, then you have to apply that method. Okay, and each method has its own advantages. So let's see, in the circuit shown below, use superposition theorem principle to determine the value of Ix. Okay, so they are asking us to find out Ix. What is the value of Ix in the circuit? Okay, you can apply nodal analysis and find the solution. That is one method. If you want to apply superposition theorem, how to proceed, that we will see. So how many independent sources are there in the circuit?
2
Two. So what are they?
10 volt and 3 ampere.
3 ampere.
10 volt, 3 ampere.
Okay. 10 volts independent voltage source and 3 amperes independent current source. So what superposition theorem states is it's a linear circuit, right? If you see the dependent voltage source is was showing on the extreme right, 2 into Ix. So it is depending on first power of some variable which is Ix existing in the same circuit. Okay, so the dependent voltage source existing in your circuit is a linear dependent source. So superposition theorem is applicable, can be applied for this circuit. Okay, so what it states is if you have two independent sources in the present circuit, you are going to analyze the circuit at two stages. Okay, stage one, you have to consider only one independent source at a time. Other independent source will be replaced by its internal resistance. Okay, for a voltage source, the internal resistance is 0. Okay, that means 0 means you have to short circuit. Okay, for a current source, the internal resistance is infinite. Okay, that means infinite means open circuit. Okay, open circuit means infinite resistance, no current will flow from top to bottom. Okay, right. So two stages means one will be considered at a time. Okay, at stage one, let's say I will consider only 10 volts voltage source. Independent current source is not going to exist in my circuit. Not going to exist in my circuit means I have to replace with its internal resistance, which is infinite. That means I have to open circuit it. Okay, so first circuit will be something like the outer loop will remain as it is, but there will be an open circuit at the center branch. That means open circuit will not be present in your, that means 3 amperes independent source will not be present in your network. That is stage one of your solution process. Right. So applying superposition theorem with 10 volts source alone. That means I am considering only 10 volt source in my circuit as stage 1. So how to solve it? So if you see here, simply if you apply KVL for this entire loop, you can solve that. Okay. Why I am calling it as Ix dash? Because this is not the complete solution for your network. We are in stage 1. So that's why I have given the variable name as, just for my clarity, I have given I am in stage 1. So that's why I have given all variables with Ix dash. Okay. So I will get some response for Ix using this circuit, and I will get some other response. Response means some current flowing using the other circuit, that is stage 2. Okay, I should algebraically add up both the currents to get the net Ix. Okay, so stage 1 says that considering only independent voltage source, independent current source should not be present in the circuit. That means I should replace with an open circuit. So that's why I have opened the terminals across this 3 amperes source. So that this is a circuit. So If you apply KVL, you can find out Ix dash. Okay. You are able to understand, right? So it will be minus 10 into 2 into Ix dash plus 1 into Ix dash plus 2 into Ix dash is equals to 0. So Ix dash will be equal to 2 amperes. Okay. Right.
Sir,
So in the, yeah.
sir, why is 2i dash 2i dash x is here?
See, why it is only a variable I am just denoting. Okay. If you want, you can call it as Ix, no issue. You remove Ix dash, you put only Ix, no issue. But you have to understand in your mind, this is not the complete solution. This is a part of the solution only. Okay.
Sir, in
Yeah.
this first circuit, only I dash x is flowing in the whole circuit. Then why at a dependent source 2i dash x is
See, if you're in your question, what it is given? Dependent
2i dash x?
source is 2 into Ix. Okay. So that means this source output, what our voltage, it is a voltage source, na? So is depending on some variable. That variable is Ix. That means the current flowing in this part branch in the direction from left to right, it is depending on that value. Okay. Right. Correct. So whatever Ix is shown here, that should be shown here. If I call it as Ix2, I should represent with Ix2. If I call it as Ix dash, I should represent with Ix dash. What it is saying is simply whatever current is flowing through the 2 ohms resistor, I am depending on that value. That's all. This dependent voltage source states that I am depending on Ix. I am depending on current flowing through the 2 ohms resistor. That's what it is saying. Okay. So since if I call the current flowing through the 2 ohms resistor as Ix dash, I should represent this also with Ix dash only. Okay. Right. This is just a
Okay,
variable.
sir.
It indirectly means current flowing through the 2 ohms resistor I am depending on. That's what it means. Okay. If you call current flowing through the 2 ohms resistor as IN, then I should replace here also IN. Because dependent source itself says that I am depending on some variable existing in the same network. Okay. So it is existing on the current flowing through the 2 ohms. It's just a variable representation. Okay. Right. You can call any variable, but the meaning is I am depending on current flowing through the 2 ohms resistor flowing from left to right. That is the actual meaning. Okay. For our understanding, we have given some variable. Okay. So that's the reason if I place Ix dash here, I should place Ix dash here. That means I am depending on current flowing through 2 ohms resistor. Okay. So if you solve this by applying KVL, you got Ix dash is equals to 2 amperes. This is not the complete solution because in the question they have asked find out Ix, find out current flowing through the 2 ohms resistor. Okay. Current flowing through the 2 ohms resistor is only, if you see here in this part, that is considering only 10 volt source, you have not got the complete solution. You are in the middle of the process. Okay. Using one source, you have got what is the value? That is 2 amperes flowing from left to right. Okay. So Ix dash is positive and you observe it to be 2 amperes. Okay. Ix dash only you have calculated. To find Ix, you have to go to the second stage of your solution. So how to do that? In second stage, you are considering the second source which is present. The second source which is present here is 3 amperes independent current source. Okay, right. So 3 amperes independent current source is present in the circuit. And the independent voltage source needs to be replaced by its internal resistance. What is the internal resistance of a voltage source? It is 0. So that's why we have replaced with a short circuit. Okay. To avoid confusion, I have simply replaced this Ix dash with Ix double dash. Okay. So that means when I see Ix double dash, I will have a clear picture. Okay, this is coming because of some current source in the present circuit, in the present study. The circuit what you have considered, I will understand Ix double dash corresponds to 3 amperes current source. Ix dash corresponds to 10 ampere 10 volt source. That is for my understanding only. That's all. Right. Okay. So if I represent this one as Ix double dash, here also it should be Ix double dash. Okay. And the voltage I have given as V double dash. Y means here it is V. Okay. But this circuit and this circuit are not same. To be frank, this independent voltage source is not present in the circuit. Okay, so if I represent with the same variable, I will get confused with the actual circuit and this second stage circuit. So that's why, to avoid confusion, I have given it as V double dash. You can give any variable, that is your choice. Okay, you can call it as V1, V2, whatever it may be. Okay, only thing is, you should understand that this is not the complete voltage. This is the voltage what I am getting only when I am considering 3 amperes current source alone. If you are understanding that, that is your choice, whatever variable you use. Okay, so in stage 2, if you see, you have a current source, you have a dependent voltage source and some resistors. So you can apply nodal analysis. Okay, if you apply nodal analysis, you can find out Ix double dash maybe. Okay, so what will happen? Try to write the nodal equation at node 1 for second circuit. Okay, so what will be the nodal equation? I should consider all the currents coming out of node 1. First of all, I have to choose a reference node. So I have chosen the reference node as this bottom one. Okay, and there is one node existing here. Okay, so how to give the nodal expression for at node 1? It will be minus Ix double dash minus 3 amperes because of this 3 amperes current source. Next, what will happen? If I call this one as V double dash minus 2 into Ix double dash divided by 1 ohm. You are clear with the third term what I have written here?
Yes, sir.
Fusion. Third term I am talking about. It is V double dash minus 2 into Ix double dash divided by 1 ohm. Okay. So this is a voltage and 2 into Ix double dash is also a voltage. If you see, it is a dependent voltage source. Okay, plus and minus signs are given, so it's a dependent voltage source. So some voltage minus other voltage divided by resistance, so that will give me the current. So all these three terms existing in your equation are currents. Okay, clear. So third term is clear to everyone, or someone has any confusion with that?
No, sir.
Is it clear?
Yes, sir.
Okay.
Yes, sir.
Okay.
No, sir, no, sir.
Okay. Please say.
Sir, in the second step, sir, I could not conclude that why we had taken it V double dash. An independent
See,
source, so it will be always, I mean, we like that we did it in the first
oh,
step. That 10 volt that 10 volt source was
okay.
always 10 volt.
Okay. Let me clarify you. First of all, you don't mix these two circuits. Okay, the actual circuit is what is already given to you, that I am breaking into two circuits. Okay, for my analysis process, superposition theorem states that if you have two sources, I can
Yes, sir.
categorize or subcategorize the actual circuit into two circuits. So this circuit is completely, I mean, no way linked to the second stage circuit. Okay, so when you're
Yes,
finding
sir.
the solution, look the circuit 1 as a separate circuit, look circuit 2 as a separate circuit. Okay, and try to solve. If you want, you
Yes,
can
sir.
call this one as V also, no issue. Okay, but you remember that the solution what you are getting from stage 2 is no way linked to solution what you have get in stage 1. Okay, because these two circuits are completely different. Here there is open circuit, but if you see here there is some current source, here there is some voltage 10 volts existing in circuit 1, here there is a short circuit. So these two circuits are completely different, but finally when you get the solution, that means Ix dash what they have asked, here you have represented as Ix double dash, you have to add up both at the end to get the net Ix from the actual circuit. Is it clear, or you want more clarity on this?
Sir, then why didn't we did that in the first step. Sir, we should
See,
10-volt circuit, 10-volt voltage source.
no. What it happens is, if you see the property of an ideal voltage source and ideal current source, okay, ideal current source will have infinite impedance. Okay, infinite impedance means infinite resistance. Okay, so that is
Yes,
the
sir.
reason why we have open circuited in this. That means the complete analysis we are doing in two stages. Okay, this is stage one that has given me some result, some response, that is Ix dash, which is 2 amperes. Okay,
Yes, sir.
if you consider stage 2, this is a simplified process only. Okay, you have removed one source and you are using only, considering only one source is existing, that is 3 amperes source existing in my circuit. I am trying to solve it. Okay, at the end
Yes,
what you
sir.
will do is, when you get the both the solutions, you will algebraically add, that means taking the sign into consideration, you will add up both to get the net current Ix, which was asked in your question.
Yes, sir.
Okay, so this is what
Okay, sir.
superposition theorem states. That superposition theorem itself states that if you have n number of sources, okay, consider only one source at a time when you are finding your solution. Okay, consider one source, find the solution, write the solution somewhere. Okay, consider another source, find the solution, write solution somewhere. Then add up both. Okay, add up algebraically both the results. Then you will get the final solution for the actual circuit given to you. That's what it states.
Okay.
Okay.
Sir, so sir, I just concluded that that 3 ampere source will always
Yeah.
be 3 ampere.
Yeah. That
Like
will be 3
that you
amp.
did in, but voltage across it may change. And
If
that
you,
10-volt source,
hmm.
10-volt source, it will be always
Hmm.
10 volt, but current across may change
Yeah.
always.
Correct. Right.
Yes, sir. Okay, sir.
Okay. So
Sir, that's
independent source
from
is
definition
yeah,
we
independent
can,
source
sir.
itself states that whatever circuit you
Yes,
connect, my 10 volts remain same. That's what independent source states.
sir.
Okay.
10-volt will be same, but current across it may not be same
Yeah,
because
current will
resistance
depend
and
on the
everything.
circuit parameters. Circuit parameters.
Okay, okay, sir.
Okay.
That's why it has changed.
Mm,
Okay, sir.
yeah,
Thank you,
that's
sir.
right. Okay, fine. So is everyone clear regarding this equation one? Applying nodal analysis?
Yes, sir.
Okay. Okay then. Fine. So now you have if you have seen this way equation one, you have Ix double dash which is unknown, Vx double dash which is unknown to you. So if you segregate, you will get some relation between Ix double dash and Vx double dash. Both are related to the same circuit. Okay. Right. So you have to find out Ix double dash. So how to proceed that? You have two equations, equation 1 and equation 2. At node 2, voltage V2. See, if you see here, at node 1, voltage is V double dash. Then current I will be how much? If you see in the circuit, right? At node 1, voltage is V double dash. Then current will be how much? Ix double dash is equals to minus V double dash divided by 2. You are understanding, na? The voltage V double dash is known to you. This is your 0 volts. So I am trying to find out Ix double dash. I am trying to write Ix double dash in terms of V1 double dash. So it will be minus V1 double dash divided by 2. Is second equation clear to you?
Yes, sir.
Yes, sir.
Yes,
Okay.
sir.
It's the same thing, nodal analysis only. Okay. So voltage divided by the corresponding resistance will give you the current flowing out of that particular node. Since our Ix double dash is flowing into the node, so you will have a negative sign. Okay. So that is equation 2. So two equations are there, two unknowns. One is V double dash, another one is I double dash. So I think you should be able to solve it. Okay. So if you consider equation 1 and equation 2 and solve that, you are going to get V double dash is equals to 1.2 volts. Okay. And Ix double dash is equals to minus 0.6 amperes. Okay. Try to solve and check whether you are getting same or not. Try to solve. Okay.
Sir,
So
sir, what is the reason behind this?
what? Any question is there?
Yes, sir, what is the reason behind this analysis?
Reason behind this analysis is if you have any complex circuit. Okay, here I am showing only two independent sources. Okay, if I have, let's say, 6 or 7 independent sources. Okay, if you use some mesh analysis or some other analysis, it may become complex. Okay, so this one, what it says is, it will, even though it may seems to be a lengthy process, it will simplify your complexity. Okay, if you have 6 sources, you can break into 6 circuits and get the solution for each circuit, each stage, and sum up all those things. That means there will not be any confusion or less chances of making error. Okay, right. If you consider nodal analysis, maybe that may become complex. Okay, so you have to choose which method I adopt. Okay, so that is your choice. If you see by using superposition theorem, I will be able to solve it easily, you can adopt this method. Otherwise, you can use nodal analysis or KVL or mesh analysis. So it is your choice. But this is one of the techniques that is available to you. Okay. So if you say when you are trying to solve something, we are trying to analyze or identify what are the methods I can approach my solution. Okay. So in that process, they have found KVL is one method, KCL or mesh analysis or nodal analysis, they have found one method, and they found this is also one method which is applicable for linear circuits. Okay. Okay. So they are just simply analyzing the circuits in different methods that are possible. Okay. Right. So if which is suitable to you, that you can choose. We are not only in the subject, in practical point of view, if you see in your circuit in a mobile or somewhere in a PCB, they will have complex circuits, right? So if they feel that this method is easy, they will try to adopt this method there and check whether the solution or the output is meeting their requirement or not. Okay, so this is the available techniques we are discussing. That's all, right?
Thank you.
Okay, so now you have got.
Sir.
Yeah.
Sir, if there are 3 independent current source or independent source, then
Yeah. Then you will get the solution in 3 stages. Stage 1, only one independent source is considered. Remaining 2 independent sources are replaced by their internal resistance. That means if it's a current source, open circuit. If it's a voltage source, short circuit. Okay, that is stage 1.
okay, sir. Okay.
Stage 2, again same. You will consider another
Okay.
source. Remaining 2 sources will be not be present in your circuit. Okay, so 3 stages you will do and 3 solutions you will get. Then algebraically you have to add all the 3 solutions, taking sign into consideration. And as I say algebraically, you should take sign into consideration, and then you will get the net result. Okay, so if you
Sir,
want,
as well
you
as
can,
current
I can
as
ask
well as voltage.
voltage also. Yes, voltage also. Voltage means you have to add voltages with the same algebraically. You have to add all the voltages. Okay, then you will get the voltage across that particular branch or element. Okay. Right. So you have got Ix double dash as minus 0.6 amperes. Okay. So what is the net current? Ix is equals to Ix dash plus Ix double dash. Ix double dash is minus 0.6 amperes. Ix dash is 2 amperes you have got here. So 2 minus 6, that is 1.4 amperes is your Ix. Okay. That means 1.4 amperes is current is flowing from left to right through 2 ohms resistor. Okay. Out of this, if you think more about this, 2 amperes is the contribution of current by the 10 volt source in the direction of Ix. Okay, and the current contribution by this 3 amperes current source is minus 6. That means it is trying to pump minus 6 in this direction. Okay, sorry, minus 6 in Ix double dash is minus 6 now, so Ix double dash is here. Okay, so minus 6 it is trying to pump in this direction. Okay, so from left to right, 10 volt source is trying to send 2 amperes of current from left to right. 3 amperes current source is trying to send minus 6 amperes. So the net current is 2 minus 6, which is 1.4. So 1.4 is the total current flowing through 2 ohms resistor when the two sources are present. If you want to cross check this, you take the same circuit, apply nodal analysis, and find out what is the current flowing through the 2 ohms resistor in the direction shown here. Okay, you will get again 1.4 amperes only. Okay, you can cross check that and you have time afterwards. Okay, so this is the way you have to proceed for a superposition theorem solution. So n number of sources are there. You will solve the solution in n stages, and finally it will be the algebraic addition of all the results or responses what you got. Clear?
Sir,
Yes,
Yeah.
sir.
sir, this source current, sir, it's flowing from up to down, na sir?
What is this Ix double dash is minus 0.6. So Ix double dash in the circuit 2. That means with 3 amperes current source, what it is showing? It is minus 0.6 is flowing from left to right. That's what it means. Ix double dash is showing from left to right, right? So minus 0.6 is flowing from left to right. Okay. And Ix dash is flowing 2 amperes from left to right. Okay. But the net will be 2 plus of minus 6. So it will be 2 minus 0.6. Okay. So it will be 1.4. Is it
Okay,
clear? Okay.
How to calculate the V?
Okay, so V, if you talk about V is the voltage. Okay, so now stage 1, stage 2 are there. Okay, so what is the voltage V? Voltage is V is the existing across these open circuit terminals. Okay, correct. So how to calculate V? That means you have to find out the voltage V between the two terminals, because your reference node is at this point, ground point. You have to find out the voltage V existing between the two resistors, between the 2 ohms resistor and 1 ohm resistor. So how to proceed to find out V?
Sir, KVL.
You can apply KVL, or you know Ix dash na 2 amperes.
Oh,
So for
right.
circuit 1, 10 minus 2 into 2. That will give you
V
V.
at that.
V, that is V1 dash, you can call it V dash. Okay. So V dash will be 6 volts. Is it clear? 10 minus 2 into 2. 2 is the resistance and 2 is the current. So 6 volts is the V1 V dash from circuit 1. Here you have seen V double dash is 1.2 volts. So you have to add both algebraically. Here it is plus sign. So here it is also plus sign. So it will be 6 plus 1.2. So something like 7.2 volts will be the V, total V. Clear?
Okay, sir. Got it. Thank you.
Okay, fine.
Sir.
Yeah.
Sir, I can't understand V, total V.
Okay, so when you talk about V also, you have two stages. Okay, so you are trying to find out the voltage across voltage of at node 1 with respect to your ground node. Okay, if you apply KVL, so what will be there? Here you have 10 volts here. Okay, you have found
Yes,
out
sir.
that Ix dash is 2 amperes. Okay, so now you apply KVL to this thing. It's open circuit doesn't mean that voltage is 0. Open circuit current is 0, but voltage will exist at this point at node 1. Okay, so how to find out voltage? You have to apply KVL for this loop. Let's say I will call voltage in circuit 1 as V dash. Okay, so what will be the KVL for this loop? Minus 10 plus 2 into
Plus 2,
Ix dash, 2x dash, Ix dash
plus,
plus V dash is equals to 0. Is it clear? This is V
yes,
dash.
sir.
Okay. So you know Ix dash already 2 amperes. Yeah.
Sir.
Yeah.
KVL is applicable only for closed loop.
Okay. Closed loop means I am denoting this voltage as V1 dash, right?
Yes, sir.
KVL means it is all the voltages you have to add up in that particular loop. Okay, I am considering this as the voltage at this point as V dash, let's say. Okay, so that means I don't know what is on the right hand side, but I am giving the voltage at this node as V dash. Whether it is closed or open, I don't know. Okay, but they are giving me a polarity called as V dash at this point. Okay, so I can apply KVL now, blindly thinking that something is there in the circuit. I don't know what is that, but some voltage is given here. Okay, that is V dash I am considering. Right, since in this circuit you are seeing an open circuit, that's why you are feeling like that. Or otherwise, if you have doubt, you can apply KVL for this entire loop also.
Okay, sir.
You can apply KVL for this entire loop, no issue. But at the end of the solution, you have to find out what is the voltage at this node. You are understanding?
Yes, sir.
You can apply KVL for this entire loop, closed loop, no issue. But your objective is to find out the voltage at node 1 in circuit 1. Okay, if you could get that, then no issue. Okay,
Sir, then we can apply KVL for open circuit.
you can apply KVL for open circuit, but you should know the voltage at that particular point. If you say this is open circuit, I know the voltage at this point, na? Okay.
Yes, sir.
Okay, you are flowing through the loop. You can apply KVL for open circuit also, but that at open circuit some voltage you have to denote before applying. Okay, then only you will be able to apply for the KVL. Okay, you are
Okay.
understanding or not?
Yes, sir.
Right. When I am denoting this voltage with V some value, I don't know whether it's open circuit or not. Since in this circuit you are seeing some open terminals, you are calling it as open circuit. Okay. Yeah, if I close this right hand part completely and say something is existing here, let's say V1, V dash, then you will feel that it's a closed circuit only. Okay. Right.
Yes, sir.
If you see in the previous examples also in class 1 or 2, we have discussed something like this scenario. Vx I have asked you to find out. You see in that circuit KVL second example, I think so. Okay. From there you can understand. Or you think in another way also, here you have 10 volts. Resistor is one which will create a drop in your voltage, right? So how much drop it will create? V is equals to I into R. I is 2 amperes, R is 2 amperes. So 2 into 2 is 4 volts is the drop across this fellow. So 10 minus 4 volts. Okay, right, how much? It should be 6. Okay. 6 volts.
Yes.
All are measured with respect to your reference node, which is at the bottom. Okay. So 6 volts is the voltage of this node with respect to your reference node. That's what it means. Okay.
Yes, sir.
Sir, excuse me, sir.
Yeah.
Sir, if we would have to find the current through 1 ohm resistor,
Yeah.
then sir, we have to reach the same approach, and then we have to find current through 1 ohm resistor, or some other approach is there.
No, same thing. See. In stage 1, what is the current flowing through 1 ohm resistor now? Stage
Sir,
1.
Stage 1 IX dash.
That is 2 amperes. So 1 ohm resistor current you have already found out. Okay.
Yes,
In
sir.
stage 2, you have to find out what is that? I current flowing through 1 ohm resistor. So how to solve that?
IX dash plus 3. Sir, KCL
No.
by applying KCL.
In stage 2, you can find using these variables only. You have already
Yes, sir.
got Ix double dash and you have already got V1 double dash. Using these two also you can find out if you want. Okay.
Okay, sir.
What will be the current here? V double dash minus 2 into X double dash divided by 1. That's all. That is this
Yes,
third
sir.
term is nothing but this one.
Okay, sir.
You understood, na?
Okay, sir.
This
Then we will add both current.
Yeah, both. In stage 1, what you got, you have to add. With sign to take into consideration, you have to add. Then you will get the current flowing through 1 ohm resistor.
Okay, sir.
Okay.
Okay, sir. Thank you, sir.
Okay, fine. If you have any doubt, you solve the same problem using nodal analysis. You will find out that Ix will be again 1.4 amperes. Okay, you can apply any method, nodal analysis or KVL or KCL, whatever it may be. Okay. So next. So till now we have discussed regarding an independent, ideal independent sources. Okay, ideal voltage source or ideal current source. But in reality, if you speak, this kind of source will never exist in reality. Okay, theoretically they may exist, but in practical circuits they are not going to exist. Okay, so now we will see what is called as practical voltage source. Okay, so that means in the previous case I told independent voltage source is one which will have the voltage across its terminals constant. How much current you draw from it, it is immaterial to it. Okay, that's what it was saying. Okay, so the voltage across me is going to remain constant. How much current you want to draw, you draw from me, I don't mind. So that's what it was saying, independent voltage source. But in reality, that kind of source will not exist. So if you consider a practical voltage source, is modeled as an ideal voltage source Vs and a resistance Rs called internal resistance or input resistance, output resistance placed in series with it. That means a practical voltage source is represented by this fashion. That means an independent voltage source with an internal resistance or output resistance which is Rs shown here. So these two combination together is called as an practical voltage source. Okay, so this is called as a practical voltage source. Right, so practical voltage source connected to a load resistance RL is shown in your figure. That means if you consider a practical voltage source, previously if I consider an independent voltage source to a load resistance RL, this RS will not be existing in your picture. But if you consider a practical voltage source, this RS will be coming into picture. That is called as internal resistance or output resistance of the practical voltage source. Okay, so this is the scenario. Okay, so what it indirectly means is if you see, if with increase in IL, whether this VL is going to drop or not. You understood my question or not? If IL is 2 amperes, VL will have some value. If IL is 10 amperes, VL will have some other value. Whether those two values are same or not.
No, sir. No, sir.
They will not be same
No, sir.
because this IL increases means the drop across this series resistance RS is going to increase. That means if VS is some value, okay, this fellow will determine how much drop will be there based on the current IL. That means if you draw more current from the, if IL is keep on increasing, the voltage across this fellow keeps on increasing, RS increases. So the load voltage VL, which is actually coming to your load. Load means the circuit what you actually want to apply. Let's say you want to apply some 10 volts to a circuit, some mic, some cell phone circuit or whatever it may be. Okay, so that circuit voltage which is actually coming to the circuit will keep on reducing with increase in the current. Okay, so what it indirectly means is I am a practical voltage source, so my voltage is not going to remain constant. Based on your current drawing, I am going to drop my voltage level. Okay, if I increase the current level, my voltage is going to drop. That is what is going to happen in a practical circuit. So if you, I mean, model it, if you consider you in the form of circuit, you have to bring some resistance into your network. Okay, so that is called as internal resistance of this voltage source. Okay, so all practical voltage sources will have an internal resistance which is called as RS, which is denoted as RS in the circuit. Okay, so if you have a 10 volt source, that RS value will be some value. If you have 100 volt source, this RS value will be some other value. Okay, so it depends upon the value of your independent voltage source. Okay, how so big the source is. Okay, you can't expect RS to be same for a 10 volt source and 1000 volt source. RS is going to vary for different sources. Okay, right. So RS is just a variable which indicates the internal resistance of a independent voltage source. So based on that fellow and the amount of current you are drawing, the voltage which is coming to your circuit will keep on varying. Okay, so this is called as a practical voltage source.
Sir,
Now, yeah.
at RL, the IL will be constant.
IL, you can't say IL constant. It depends on the value. Now it's a circuit, na? Vs, let's say 10 volts is there, Rs is let's say 0.5, and RL is let's say 20 ohms. Okay, so what will happen? IL will be, this is 20 and this is 0.5, so this is 10. So 10 divided by 20 plus 0.5, 10 divided by 20.5, that will be your IL. Okay, if I remove this RL and place very high value resistance, let's say 100 ohms. So what will be IL now? This is 10, this is 0.5, and this is 100. So it will be 10 divided by 100.5. So IL will be some other value. Okay. You're understanding, na? So IL is called as load current. Why it is called as load current? It is determined by the value of load resistance you have connected. So what resistance I connect, that will determine how much current flow in the circuit. Okay. Right. So each load will have their own resistance. That resistance will determine how much current to flow in the circuit. Okay. So IL will keep on varying based on it depends on basically RL, that's all. IL depends on RL. Okay. Right. Okay. So coming to practical current source. So what practical current source is? Whatever, the practical current source says that how many elements you connect across parallel to me, I won't mind. My current will remain constant. That's what ideal current source says, right? I am going to supply constant value of current from my side. How many elements you want to connect, you connect. I won't mind. That is what an ideal current source is. But in reality, this kind of current source will not exist. So there will be only a practical current source. So how to model it is practical current source is defined as an ideal current source in parallel with an internal resistance. Okay. So internal resistance is RT I am considering. Okay. You can call it RS also. Okay. Let's see what is that. I'm saying that RP. So how to draw the circuit? It will be in this fashion. Okay. Same load resistance we are considering just for denotation representation. Okay. So this is called as a practical current source. An ideal current source in parallel with its internal resistance or with resistance RP is called as a practical current source. Okay. So this is how you have to represent a practical current source, and this is how you have to represent a practical voltage source. Is it clear? So what it means is some amount of current is actually flowing into RP. Okay. Right. So obviously some current will flow through the resistance RP. So remaining current will only be coming to your load. Okay. Right. So that means in practical circuits, based on the load resistance and the internal resistance RP, some amount of current will be flowing into RP and the remaining only will be coming to your network. Okay. So here you will see an example of source transformation. That means if you have a current source, as shown here, practical current source I'm talking about. Okay, you have a 3 amperes current source in parallel with a resistance 2 ohms. Okay, so this is the resistance 2 ohms is the internal resistance of your current source. Okay, so we can actually change this circuit, what is shown here. A practical current source can be converted into an equivalent voltage source. That means these two sources are similar. Okay, these two circuits are similar. How to do that? You are understanding, right?
Yes, sir.
Yes, sir.
Okay, so if you have a current source of 3 amperes in parallel with 2 ohms resistor, you can convert into an equivalent voltage source with some resistance. So how to do that means, since this is open circuit, okay, 3 amperes will have to flow only through this 2 ohms resistor. So what will happen? 3 into 2, that will be 6 volts is the voltage existing across this 2 ohms resistor. Correct? 6 volts. So that voltage, if you place here and place the same resistance R in series with the voltage source what you have already got, that is called as an equivalent voltage source. That means this circuit and this circuit are similar or identical from circuit point of view. They are not going to vary. In fact, the opposite is also true. Okay, if I have an independent practical voltage source of this fashion, which is shown here, I want to convert it back to a current source, it will be the same. Okay, so how to do that means you have to divide this resistance with this voltage with this resistance, that is 6 divided by 2, that will be a 3 amperes current source. Okay, and the same resistance what you have seen you are having here, that if you place here in parallel with the current source, that will be your practical current source. That means practical current source can be converted to an equivalent practical voltage source. Practical voltage source can be converted back to an equivalent practical current source. Okay, both are similar, both are identical. Based on the application, if you want, you can convert from this way to that way, or in the other way also you can convert. Okay, so right, so quickly go through this example. Okay, so here some circuit is there. You have 5 volt source with a resistance of 5 kilo ohms, and you have 47 kilo ohms here, and 1 milliampere current source. So the question is, in the circuit shown below, compute the Ix through the 47 kilo ohms resistor. So they are trying to find out Ix. Okay, you can apply any method. So here we are trying to use the source transformation to find out, to simplify your circuit. So what you have to do, first of all, if you see here, you have a voltage source with a series resistance. That means up to this point, that means voltage source with 5 kilo ohms seems to be a practical voltage source. I can convert into an equivalent current source. Okay, how to do that? Equivalent current source will be 5 volts divided by 5 kilo ohms. That will be my current source, and I will have a parallel resistor of 5 kilo ohms. Okay, so if you see here, 5 volts divided by 5 kilo ohms, that will be 1 milliampere. So that 1 milliampere in parallel with this 5 kilo ohms. So that's what this 5 kilo ohms was placed here. That means this dotted line, the left hand side of this dotted line is same as this part. 1 milliampere in parallel with 5 kilo ohms up to this point is same. The dotted line, left hand side of the dotted line in first figure 1, is same as this part. Both are identical. Simply I have converted a voltage source with its internal resistance into a current source with its internal resistance. Is it clear? So why I have done? If you see here, now you have two current sources and both are existing across the same pair of nodes. So now I can club these two. So if I club these two, you will get 2 milliamperes. Now I can apply current division rule to find out the current flowing through 47 kilo ohms. Okay, so total current 2 milliamperes into opposite resistance, which is 5k divided by 5k plus 47k, that will give me Ix. Okay, but one important thing you have to consider here is, if you see here, when you are converting the practical voltage source into a practical current source, the direction of current, that is important. Okay, plus sign is on the top. Plus sign for the practical voltage source 5 volts is on the top. So your current should be in such a direction that current will come out of the terminal. That means your arrow in your current source should be towards top, because plus is on the top. You have to have current direction towards that direction. So that is the only thing you have to make a note of it. Okay, is it clear to everyone?
Yes, sir.
Sir?
Yeah.
Yes, sir.
Yes, sir.
Any doubt is there?
Yes, sir.
No,
Yeah.
sir.
So okay, any doubt is
Sir,
there? Please let me know.
we convert that. Yes, sir.
Sir?
Like in the example, can't we convert 1 milliampere and 47 kilo ohm into that voltage source, sir? Like we did in above example.
What you are talking about?
Sir, why can't
Sir,
we convert that
sir,
40?
Only one person at a time. One person at a time, please.
So why can't we convert that 1 milliampere source into voltage source?
Yeah, you can do that also. You can do that
For-
also. No, you can do that also. No issue. But the question what they have asked is find out Ix. Find out Ix. So if you do that, your Ix is not going to be defined. If you do that, what happens is Ix you will not be able to find, because Ix will be changing, na? The direction of Ix is from top to bottom. If you convert into an equivalent voltage source, it will be something like left to right or right to left. Okay, so that means what they have asked, you are actually going somewhere else. You're understanding, na? The variable Ix is going to be unidentified if you do that approach. Okay, the variable Ix is already defined in your question. It is flowing through the 47 kilo ohms resistor. Okay, so that will get undefined if you try to convert on the this one milliampere source. So that is the reason why I have not converted that, so that my Ix will remain as it is, and I will try to use the other side and try to convert it. Okay, because the variable which was already defined or asked in your question, that should not disappear, that should not go somewhere else, that should remain as it is. Okay, so that's why I have not used that approach. Clear? So any other question?
How to apply nodal analysis if we have independent voltage source in one of the branches, sir?
In this circuit you are talking, or some other circuit?
Sir, in the before circuit, you said no, sir. We can also use nodal analysis to find this.
1 second, I will try to go back. So if some other class is going to start, people who don't have doubt, they can leave. Okay, so I will clear his doubt.
Okay, sir.
Yeah. Hello.
Excuse me, sir.
Yeah.
Sir, I wanted to ask that only slides will be available to us, sir, like you are sending the whole lecture video.
I am going to send only the lecture video, not slides. Okay. Lecture
sir.
video will be coming to you. And next time I will upload in Google Classroom. I think you have got that thing.
Yes,
Huh?
sir. Yes. Sir.
Okay. So you try to download from Google Classroom. I will upload all lectures there. Okay.
Okay.
I
Sir?
think my yeah.
Sir, I wanted to ask that I mean, just I am like feeling that the illustration you given above, it should be like 3 ampere and 2 ohm. So it's like 3 to just 6 volt. And just 6 volt source should be there and not 2 ohm resistance. Sir, I'm just
No. We are
observing like
talking
this.
about converting a practical current source into a practical voltage source. Okay. So if you have only 6 ohms, that is called as an ideal voltage source. Okay. Right. Ideal voltage source means that whatever you connect across my load terminals, I am going to remain 6 volts as it is. But practical voltage source says that I am now a practical voltage source, so I am going to have a reduced voltage at the output terminals. That means these open circuit terminals, what you are seeing here, that will have a reduced voltage. If you have only 6 volts, that can't be called as a practical voltage source. Okay. If you have doubt, you try to convert this back into this fashion. Okay. So both will have, or you have one more doubt, na? Let's say in the practical current source, you are listening, right?
Yes, sir.
Hello? Yeah. Across these 2 ohms, resistor, you convert 1 ohm, let's say. Okay.
Yes.
Okay. So that means the load resistor, that means some load is there, that load has a value of 1 ohm. Try to find out what is the current flowing through that 1 ohm. Any method you apply. Okay. Try to find out what is the current flowing through that 1 ohm. Now connect the same 1 ohm across the open circuit terminals here in the equivalent voltage source, and trying to find out what is the current flowing in the 1 ohm. You will get the same value of current flowing in both. Okay. Right. If you remove this 2 ohm resistor, you will not get the same value. You can cross check that. You're understanding, na? Across the open
Yes, sir.
circuit
Yes, sir.
terminals of current source, you connect some value of resistance, whatever you choose. You can connect 100 ohms, whatever it may be. You connect 100 ohms here, find out what is the current flowing through 100 ohms. Same 100 ohms you connect on the other side, that means equivalent voltage source. Find out what is the current flowing in the 100 ohms. Both will be same. Okay, right.
Okay. Yes,
But
sir.
if you remove
It
the
means just
it,
yes, sir.
Sir,
yeah,
Sir,
yeah, yeah.
firstly we tried to do that, and then we got same result, so we can just apply this.
Actually, if you see that how they have approached to this conclusion, they have analyzed that and they have come to this approach. Okay, so whatever
Yes,
I'm giving the conclusion, after analyzing that only they have come to this conclusion. This result was declared based on analyzing that circuit. They will connect a load resistance RL, they will find out the equations and they will solve those equations. And if you set here it is RP, na? Here it is
sir.
RS. If you see practical case, I have defined this as RS and I
RS,
have
yes,
defined
sir.
this as RP. So when
RP.
RS is equals to RP, you will get the result same. You are understanding, na? So that
Yes,
means
sir.
if you connect a load resistance RL of different values, okay, let's say RL is equals to 50 ohms. I am connecting in both the
Okay, sir.
circuits. Okay, and I am
Yes,
trying
sir.
to find out current in both the cases. Okay, so if you have only 2 ohms here and 2 ohms here only, your solution will be correct. Otherwise, if you have 2 here and if you have 10 ohms here, then it is not going to be correct. That means they have analyzed connecting an RL load and they observe that when RS is equals to RP, these circuits are both identical. RS is equals to RP, the both circuits are identical. Okay, so that conclusion they
Yes,
have
sir.
got, and from that conclusion only I'm explaining this. Okay, so
Yes, sir.
if you remove the 2 ohm resistor, you are saying that RS is equals to 0 ohms. RP is equals
Yes,
to
sir.
2 ohms, RS is equals to 0 ohms. So that is not an equivalent. That means these two are not same if you do that. If RS is equals to
Yes.
RP only, it is same. Okay, the two circuits are identical. Clear?
Okay, sir. Okay. Sir, I just asked this because I was having a different feeling for this. So that's why.
Okay,
Okay,
okay.
sir. So now
So
I will try to do that and then I will be clear about this.
yeah. You connect some value of resistance in both the circuits and try to find out current across the current flowing through that resistance. If this is the scenario only, you will get the same current. Otherwise, you will get different currents. Okay.
Okay, sir.
Check it.
Okay.
Check
I
it.
will
Check
try
it.
to do this. Okay, sir.
Okay.
Thank you, sir.
Fine. Okay then. So we'll leave for now. So if something is
Sir.
there, we'll yeah.
Sir, why we can use 2 ohm resistance in parallel with 6 volt
here circuit 2.
here? Yes, sir. Yes, sir.
So see, in the previous case you have seen, I'm not able to go back because of something I struck here. Okay. Recorder, I will stop.